Hi, we're still looking at exponential and logarithmic functions, but now we're up to 5b and we're just revising the differentiation of exponential functions. We first of all just need to recall what we did in our year 11 course, and that will be remaining the same. And that says that when we differentiate e to the x, we still end up with e to the x. And we will use that right through this topic as well. The other thing that we learned in year 11 was when we differentiate e to another function, what we do is we differentiate our function, and that comes down to the front, and our e to the f of x stays the same. So let's just have a look at a few examples of that. But before doing that, let's just quickly jump over to the formula sheet and see what is on our formula sheet. Okay, our formula sheet shows us the fact that if we have a function e to the power of f of x, then our derivative, our first derivative, is going to be f dash of x, e f of x. So that's there to remind us. So that's a nice thing that we don't have to memorize. Okay, so let's jump back into our exponential functions and we'll see if we can have a go at some of the questions here. Okay, first of all, we want to differentiate the following. So pause the video and have a go. You should be able to do that from year 11, but what that's telling us is when we differentiate the function, we're going to differentiate each part separately. So differentiating e to the x, we end up with still e to the x. Differentiating e to the minus x, we need to differentiate minus x, which becomes minus 1. So we're going to get minus, and our e to the minus x will stay there. So that's our first part. Our second part here, b, we're going to differentiate y is equal to 5e to the 4x minus 3. So we're using this rule over here. So down the front we have a 5, but we're going to multiply that by the derivative of our power here. So the derivative of 4x minus 3 is 4. The 4 comes down the front and gets times by the 5 that's already there. And the e to the 4x minus 3 stays there. So what we end up with is 5 times 4 is 20, e to the 4x minus 3. Okay, let's keep going. Let's differentiate the following using additional techniques. This one's going to be no different than what we did in year 11 again. And the same rule as we did up above. We have a function in the power. So when we're finding the first derivative, and again, you can write it as dy dx if you like, instead of y dash, that's okay. Let's differentiate this function and we end up with minus 2x. Our power is still the same, e to the 1 minus x squared. That one's fairly straightforward. This one's a little bit harder. We need to remember what happens when we have something of this form. So we have a function that has a power above it. So what we're going to do is to get our y dash, our 4 comes down the front. Our e to the 2x minus 3 stays there. The 4, we take 1 off to become a 3, and we then have to multiply by the derivative of what's inside that bracket as well. The derivative of what's inside that bracket is the derivative of e to the 2x, which is going to be 2e to the 2x. The minus 3, we don't, when we differentiate that, we don't get a value, but now we need to neaten it up. The 4 times the 2 gives me an 8. The e to the 2x goes out the front, and I've also got e to the 2x minus 3 to the power of 3. Okay, so when working through this topic, we need to be familiar with the product rule and the quotient rule. Now, this first one here, we're going to be using the product rule to differentiate because there are two separate functions. There's one that contains x to the 3 and one that contains e to the x. Now, what I want you to do is I don't want you to think you know the product rule. I want you to get the formula sheet and I want you to copy it down, because what a lot of you did in our last exam at the end, it was our first year 12 assessment task. You knew what you were doing, but you wrote the rule down wrong. So you need to go back to your formula sheet, and I'll jump back across here. And we need to find our product rule and our quotient rule. So you need to be familiar what that means. Product means multiply. This is our product rule because we're multiplying two separate functions together. This is our rule. You need to write it down. And then when we look at the next question, it'll look at the quotient rule. The quotient rule, quotient means to divide. So there are functions that are divided. This was the one that was particularly done quite badly in our last assessment task. So you don't need to memorize it. You've got it given to you. So don't make the mistake of getting that done incorrectly. Sorry, I've just jumped to the wrong page here. Because it is given to you. Okay, no allowances will be made in the exam for you getting the questions written down incorrectly. Sorry, not the questions, but the rule written down incorrectly. So the product rule says that when we're finding y dash, it's going to be v du dx plus u dv dx. And what that means is our two functions times together, the first one we'll call u, the second one we'll call v. So I will let u be equal to x to the power of 3, and I will let v be equal to e to the x. So then we need to differentiate each part. So du dx then will become 3x squared, and dv dx will become 6x. So what we then need to do is just pop that into our formula. So that will give us v times du dx, which is this one times this one, e to the x times by 3x squared, and we'll neaten that up in a minute, plus u times by dv dx, which are the other two. So if you set it out like this, you're basically getting the cross of each of them. X cubed times by 6x. Let's neaten that up a little bit. Y dash is going to be 3x squared e to the x plus 6x to the power of 4, which we could actually factorize out and pull out an x squared. So we get 3e to the x, or actually we can pull out a 3x squared. Let's neaten that up again. Pulling out a 3x squared, we get e to the x plus 2x squared as our answer. Okay, next one. Now, in this case, we have a quotient. We have one function divided by another. That means we need the quotient rule. The quotient rule involves a division. This was the rule that was written down on your formula sheet, but was done, the transferring of it to your paper was not done well by most people. The rule is v du dx minus u dv dx all over v squared. Again, you don't need to memorize it. It is given to you, so you need to just get your formula sheet and copy it down. Okay, u and v. So u is e to the 5x. So du dx is going to be 5e to the 5x. We have our v on the bottom, which is x. So our dv dx is going to be 1. So our formula gets us to do v du dx, that one first, and then that one next. And the v squared on the bottom, a lot of people forgot as well. So v du dx will give us 5x e to the 5x. I've just neatened it up because I've put it in straight away. Take away our u dv dx, which is just going to be e to the 5x. Please remember to pop it all over v squared. Okay, there's our answer, but I would like to factorize that. So I would like to pull out an e to the 5x on top. So I would get 5x minus 1 all over x squared, and that is my answer. Okay, let's have a look at what we've got coming up after this. I can't remember if I've got any under here. And I think that's all of it. That's all of it. So what I've also popped in our OneNote is sections for 5A and 5B. All that has in there are some of the textbook questions, the rules, and some help for you there. So go and have a go at exercise 5B. Any questions, you get to bring them in and I will help you out in class.